Hi, everyone. I'm Colin, and that's XY. We are data scientists from Riot Games down in LA. We've been using Spark for the past 6 months, and what we're really excited to talk about today is how we've been using Spark to really improve the gaming experience for our players. Now, the title that most people know us for is called League of Legends. It's an online game, multiplayer, competitive, team-based game. And as a player, you get to choose from one of several champions, over 120 in fact. Each of these champions has a unique set of abilities, an interesting backstory, and oftentimes you can customize the appearance if you so choose as a player, using something called skins, which we'll talk about more. Now, you're placed on a team, and your team works together basically to gain control of a map, with the victory condition being that you overrun and destroy the enemies or the opponent's base. We have a lot of passionate fans. We're really grateful for that. We don't think it's quite by accident. We like to believe that it's due to our core philosophy as a gaming company, and that we really aspire to be the most player-focused game company in the world. That's a tall order. And one of the ways that we hope to accomplish this goal is by informing a lot of the decisions that we make with data, and what turns out to be a lot of data. So the idea of this presentation is to go through some of the interesting questions we can ask with our data and how we've been leveraging Spark to solve those problems or to address those problems. And to do that, I'm going to use an in-game screenshot. This is taking place near the end of a game where a team is already in an enemy's base, starting to take down their defenses. And I'll start in the top corner. We have this champion, Draven. And at this point in the game, Draven is responsible for the majority of the damage output from his whole team combined. So is this player really good, or is the champion itself unbalanced and like overpowered, as would be called in gaming terms? We can address that. So we can look at not just this particular game, but all games where Draven is participating, and we can see with our data how that character pairs up against other teams. So it could be that in this particular instance, the player behind Draven is just really awesome, he's doing great stuff, and that's why his damage reflects that. But on balance, we really want to make sure the integrity of the game is preserved by having good game balance. So here's another less fortunate activity where poor Rise, he's dead. Before he died, the person playing this character was complaining that their network connection wasn't up to par. Oftentimes it's known as lagging hard, and this is exactly what happened. We collect a lot of data based on network performance from our players, and so what we want to do is we want to leverage that to see, is this player's ISP having trouble? And if so, is there something we can do to fix that? So finally, here's our team's mage, Lux, my favorite mid lane character. And this particular player chose to customize the appearance of Lux with the Star Guardian skin. And in fact, this player really enjoys playing the mage type and likes to have other appearances for those characters. So there's a lot of content in our game. So what we want to do is based on preferences from other people who play Lux, is there some other content that this particular player doesn't know about that we could recommend that we think that they would enjoy? It's a recommendation system. To answer those questions, we need data. The more, the better. And again, very fortunate that there's a lot of people that play the game across the world, tens of millions. We're collecting a lot of data every day that we have to keep up with, and now have a data warehouse that's several petabytes in size. So with that data and that sort of scale of data, how are we tackling it? Our infrastructure is pretty awesome. So I'm only going to describe a couple of the things that are more pertinent to this talk. But in general, we're using Hive as the main point for all massive scheduled ETLs, data pulls, ad hoc queries. EMR and Hive, that's kind of our go-to, our staple. More recently, as a company, we've been adapting our infrastructure to be more event time driven, or basically real-time streaming with Kafka. And we feel that's going to unlock a lot of interesting new problem spaces for us, particularly when it comes to real-time monitoring or fraud and anomaly detection. The missing link here is that typically we're using these awesome tools to reduce data into a size that fits on our desktop. And from there, we'll do data science, we'll do analytics. And that obviously limits the scale of the types of problems you can solve if you're only doing it on a laptop or a desktop. So in short, our infrastructure is pretty awesome. It's been scaling fine. We're adapting. We're building it out. But a lot of the tools that we're using to analyze this data, we're not scaling. Recognizing that, we wanted to evaluate different technologies, and ultimately we settled on Spark for a number of reasons. It checked off a lot of boxes for us. So why Spark? We're a game company. We like to have fun, so I'm going to have a little fun with you as I go through some of the check boxes. SQL for us, very big thing. All of our data scientists and data analysts are heavily invested in using SQL to access and manipulate data. And it helps that, and I'll show this later, Spark SQL for us seems to be pretty performant. Streaming. We're building out the streaming architecture. We wanted to make sure we had the tools that could interface with that and that we could do real-time analytics. Spark Streaming seems to address this quite well. Spark ML. Machine learning, obviously a big thing for us. We're data scientists. A lot of problems that we want to solve. If you were at the keynote this morning from Microsoft and you saw this awesome facial recognition software that could assess mood, normally when you see this picture, you kind of attribute it to like something awesome, but as it turns out, this toddler's very angry. So good one for Microsoft for catching that. Finally, and this is really more of a Databricks point, but we wanted to free our data scientists and our analysts from kind of the burden of cluster management, spinning up clusters, making sure they're healthy. So having a managed Spark solution, such as the one Databricks provides, is really awesome. We can spin up a cluster, do some work, spin it down when we're done, and move on. It's really awesome. So those are the whys that we use when we talk about going to Spark. How do we actually use this in our day-to-day work? So there's 3 different sections. I'm going to start with this first one. This is this common phrase here that data scientists, data analysts spend the majority of their time just prepping data for further analysis. So it's really important to get that as efficient and as right as you can. So in this section, we're going to talk about how we play with data, to use a gaming theme. So I'll walk through my particular workflow prior to Spark when it comes to pulling data. And the scenario is maybe you're hopefully familiar that you have your desktop and you pop up an editor. You craft an SQL query. In our case, I have to transfer that query to our Hive interface. I'll execute the query. It fails because I'm not good all the time. So I have to iterate on that, and eventually it does work. Eventually the query will succeed. But now I'm competing on this EMR cluster against other users who are also trying to do queries. And our tables are large, extremely large in some cases, so it's really slow to finish the query. And then finally, when the query does complete, I have to transfer that data back to my desktop for further analysis. Altogether, this is highly inefficient because the data is separated from the tools that you use to play with it. So this is where a notebook on top of Spark has been really awesome for us. So you can have a cell open, you can craft an SQL query, you can debug it right there. When it finally succeeds, you have the data right there to do plotting or further analysis or what have you. And this is awesome. But it wouldn't be if it wasn't very performant. So what we wanted to do was just some simple benchmarks on typical queries that our data scientists and analysts do, and measure their performance in terms of query runtime in minutes. So in this example, I have 2 clusters. I have our standard EMR cluster that we use versus a Spark cluster that would cost the same amount of money in Amazon. And there's different categories here. And at the very top is a simple data enrichment plus aggregation activity. The performance is more than 50% better using Spark SQL. Simple joins, so large table versus small table joins. This is an extreme example, but by and large, all of these more simpler join activities really greatly outperform their EMR counterparts. When we get to the really complex joins, these are the bottom 3 charts on this, the performance is not as great, but it's still better. And And all it is just a drop-in replacement. So you take your Hive query, you pop it into Spark SQL, it works better. So that's pretty awesome. In fact, the takeaway for this section is that playing with data or just getting your data ready to do the work that you need is a lot better using Spark. I'm a Trekkie, so I had to put that in. So next topic is on streaming. And what are we doing with streaming? I'm particularly passionate about this next section as a gamer myself and having died and done silly things because my network connection was terrible. So what we wanted to do with Spark Streaming was to see if we can improve for our players their network performance. So with games such as League of Legends, and it's not the only one, there's other games that are also dependent on a stable connection, you really need solid internet. But the problem is the internet was not designed with gamers in mind. So for this player in Montana, his traffic to our game servers over in Chicago may be routed in a really non-optimal way. All these extra path lengths leads to extra latency. That leads to decreased reaction time, which is the difference between landing a skill shot or being hit by one by an opponent. So in short, the existing network really limits our players on their network experience. So to fix that, Riot decided to build their own. So what do I mean by that? This is just a map of the US, but the Riot Direct initiative within Riot, we've built network POPs or points of presence all over the world. And the idea is that we can peer with your ISP. And by peering, I mean we physically connect a piece of fiber optic cable between our network and yours, whether it's AT&T, Time Warner, Comcast, you name it. And by doing that, we have much greater ability to more efficiently route your traffic directly to our game servers. This is a big win for our players. And we know it works. We've done lots of studies and have lots of data that really shows that this works. So great, awesome tool that can help us fix player pain around poor network conditions. The problem is there's a lot of networks in the world, a lot of players. How do we find where we should focus our attention? That's where Spark comes in. So of this plot, this slide, the number to keep in mind is this, the one in the middle. Roughly 200,000 different unique city ISP combinations. It's impossible to build dashboards to monitor them all. We do have dashboards that monitor sort of the top ISPs, but really to monitor all these is impossible. So what we really want is a tool that helps us focus our attention so we know where to go and fix problems. So essentially, what we want to model is network metrics such as player count, or CCU, player concurrent users, and average latency, or packet loss, or other metrics, as a function of time. We want to model that and then apply machine learning techniques so that we can detect when things go wrong. So in this particular case, an ISP has decided to route traffic in a different way than they historically were. And this has resulted in extra path length, which has increased the average latency and therefore negatively impacted the network experience for any player that's on that ISP. We also detect things like this. These are also quite common. These are sort of short bursts of poor performance, typically at regular times of the day. We want to identify these and see if we can work with the relevant ISPs to improve the network conditions for our players. So the way we've been doing that is with Kafka and a couple of other technologies. So in order to have the dashboard so that we can kind of plot latency versus time, the stream is being consumed by Elasticsearch, and this has been great for us. Works really well. Our network engineers can zoom in on an ISP. They can log in to whatever they need to do to help the relationship and improve the performance, tweak some knobs, and they can actually see the improvement in real time, which is amazing. We never really had that capability before we adopted streaming. On the alerting side, the Kafka stream is also consumed by Spark. And what Spark Streaming is doing in this case is it's aggregating the data into manageable chunks. It's then comparing that chunk of time and average latency against a model that's built off historical records. And then if necessary, if it sees that there's a discrepancy, it'll raise an alert. And this feeds back in the sense that those alerts get raised, the engineers can then tune their dashboard to go look at the problem, contact the ISP, and hopefully effect in a solution. What's the takeaway? Another takeaway, I'm also a Spider-Man fan. It works really well, in fact. The API is fairly intuitive. I'm not an engineer by trade, I'm a data scientist. So the fact that a data scientist can stand up something like this on their own is awesome. There are some tricks that you have to do with 1.6 Spark Streaming around this concept of event time. Maybe you've heard things like that from other sessions, but we know this is going to be a lot easier in 2.0, and we're really excited to start playing with 2.0 when it comes out. Okay, finally, all of these things are not really directly seen by players. These are behind-the-scenes things that we've been doing to improve the player experience. So I'm going to ask XY to take us to the last step and show you an example of where players directly see an output of how Spark can help their experience. XY.
Right. Thanks, Colin. So the next use case we want to talk about is a player-facing feature we built. It's our secret store that is powered by a recommendation system. And we built this recommendation system using Spark and Databricks. So as Colin has mentioned, we have a lot of champions in the game. And each champion is coupled with a very unique playstyle. And our players can actually choose from over 120 champions. And we have players who really love to play a warrior champion who can just stay in front of the line and tank the damage and for the team. We also have champions who are has high mobility and can strike from nowhere. So there are all kinds of champions our players need to choose from. And on top of that, actually for the same champion, you can choose to make this champion look different. For this particular champion, Garen, you can make him look like a rugged look like the one on the left, or like a classic armored knight's evil one or less evil one, or put some modern taste on him to make it more like an army commander. So we have more than 120 champions, and each champion has multiple unique skins that you can customize them. So that gave us a lot of champion skin combinations for our players to choose from. And if, let's say you're a player and you want to find the champion skin you want to use or you want to buy, and then you log onto the store, it's not too easy for you to actually navigate the store and scroll down all these pages, tens of pages, hundreds of pages to find what is exactly what you're looking for and what is the champion you're mostly interested in. So a very intuitive idea come from here is instead of having our players to navigate the store and try to find what they're most interested in, how about we generate a personalized recommendation to our players so that once they log on to the client, they'll be able to see, okay, this is the champion that I'm most interested in, and this is how I want to make this champion look like in the game. And then they can just go to the game and have fun. So, but recall that we have tens of millions of players. And we have over 1,000 champion skin combinations. So it's a pretty big matrix to factorize if we're thinking about building a recommendation system. So another intuitive follow-up question to the idea of personalized recommendation is, why bother? Why factorize such a big matrix if we can just recommend to our players the most popular champion or the most popular skins? And I want to use let's use a basketball as an example because we're in Bay Area. And now, in addition to being the World Center for Technology, now it's a World Center for Basketball as well. So let's say we want to recommend to basketball fans content or stories about a star, a basketball player. And we decided that we want to recommend to our player, Steph Curry, this young gentleman, stories about this guy. And it actually may work pretty well for a lot of our fans. And actually, for some fans, a big chunk of the fans, it works very well. But when we think about it, why it works so well for this particular audience is because this is their star. His story, his play style, his journey speak to these players. The flip side is, what if, for some players, this player, his journey, especially what he did in the past few weeks, it doesn't speak to the audience, and we will have some suboptimal audience experience from this recommendation. So it actually makes a lot of sense for us to generate personalized recommendations for the basketball fans. And back to League of Legends. In League of Legends, each player is specialized in a few champions. And even for the professional players in esports, they just specialize in several champions. And there is a big variance in the champion or skin preference, even within a very close group of friends who play League of Legends on a day-to-day basis. For example, so Colin really loved playing mid lane champions like Lots. And I really love playing support champions like Thresh. So even though we play together, we actually have very different preference on the champions as well as the skins. So that means it makes more sense even for us to generate recommendations based on personalized preference, even more important than in a sports fan group. So, but again, in order to do that, we need to deal with a pretty big matrix. And to put that number into context, a lot of you guys may be familiar with the Netflix price. So the Netflix price, their data set is about less than 500,000 users and about 20K movies to rate. And here is a pretty big matrix over here. With less than 500,000 matrix that Netflix data set has, you can actually dump the data onto your local machine and use some of the recommendation libraries like Crab or Suggest, or even you can write your own collaborative filtering or matrix factorization algorithms yourself. It's pretty straightforward to do that. But with this scale, we won't be able to do that. So that's the place where Spark shines, and it actually handles the big matrix factorization very well. So this is a demonstration of how we actually make it happen. So our game data and player behavior data is in Hive. And recall that we don't have player rating on on their preference about our champions or skins. So we need to make an inference based on their behavior. We basically need to have implicit rating about our champions and skins. So we need to do a lot of exploration, and we're using Spark SQL. The beauty of Spark SQL is the notebook interaction is very intuitive, and we can very fast prototype and iterate on what features we want to use to actually imply for the implicit rating. And once we have the features figured out, and we can literally go to the next cell of the notebook to do the modeling in the recommendation engine, either from the MLlib, or we can write our own recommendation and run it against Spark Core. So, and the notebook feature makes it a very interactive and very iterative process for us to actually do the modeling development, feature engineering, and model selection. And once we have built the recommendations, we can use the features on provision the Spark cluster, as well as scheduling the job to make it automated. And what the players see when they log onto the server, instead of tens of pages of champions and skins they need to choose from, is a list of the personalized recommendations. They can just find what they like and start playing the game. And we got very positive player feedback, and we get very high player participation rate, as well as very positive player sentiment. So overall, the takeaway, the notebook and Spark SQL, they enable us to do very fast prototyping. It's especially helpful when data scientists are working with a product team, that we can incorporate the feedbacks from a product team and figure out what is the right model that the product team really wants, and what is the objective that we really want to optimize towards. And also the MLlib, the recommendation library on MLlib, works actually very well on pretty big matrix. It's very fast. And it's very straightforward to move from model development into production using the provision of the Spark cluster, as well as scheduling the job. So as a summary, we have talked about how we're using Spark and Databricks to basically, the Spark SQL is helping us to make prototyping and exploratory analysis even faster. And Spark Streaming basically opened up a new territory for us to build faster and better near real-time fraud and anomaly detection, so that we can react faster to improve the player experience. And the recommendation system, the recommendation library here is handles big data pretty well and enable us to deliver some player-facing features to our players. And also, we are rethinking some of the machine learning problems and ideas that at one time seems to be too large to us. And now we have Spark. We can revisit them. And we're also brainstorming a lot of new cool ideas about machine learning, how we can deliver play experience to our players. So it's pretty safe to say, with Spark, I think we're just getting started. And there are more exciting things will happen, and we're trying to make it happen. So if you are interested in learning more, come talk to us, and we're also hiring. So thank you.
Questions? I'll run the microphone over to you.
I'm just curious, how do you productionize the recommender system? I mean, you port it into some API, or just the data feed back to the database and whatever.
So right now, we're working on that. So right now, it's not a real-time recommendation to our players yet. So we have a landing zone for the results, and then the engineers from the data from the server side, they pick up the data from the landing zone, and then they push it to the client server. But we're working on making it more real-time, more reactive. Yeah, that's a great question.
I had two questions for you. The first one was, what was the infrastructure you provisioned to do matrix factorization for that large ALS, or the large matrix that you had for recommended system?
Yep.
The second question was slightly tangential. The big problem with LoL right now is that we are not having queue matching, right? When you have matchmaking, there's a very large queue, especially since patch 6, right? So are you guys thinking about, how are you guys thinking about that particular problem for matchmaking?
Okay. So I'll talk the provision. So it's a pretty tricky. It's a great question, and it's pretty tricky to figure out what is the right size of the cluster you want to do provision. I want the provision for the matrix factorization, and my answer to that is actually a pretty big cluster you need to spin up for this size. And we don't have actually figure out what is a systematic way to, based on the size of the matrix, how many clusters you need, how many nodes you need. But we just we try it and figure out a way that is good enough to run it. And for the matchmaking, no, if have anything? Or?
Well, this is definitely, we're aware of that. We have data scientists that are involved with that. There's actually more Rioters here, so if you want to approach us after, we can have a more detailed conversation about that for sure.
Yeah, matchmaking is one of our focus. We do want to make sure that whenever you log onto the game, your opponent is at the same level of skill as you are. We don't want to have a one-sided game, so we put a lot of efforts onto that, and there are a lot of machine learning and data science efforts into that as well. So we can talk offline if interested.
It is very bright.
Okay. Well, thank you everyone for coming.
Thanks
Thank
all.
you guys.